Hello everybody, in this video we're going to be going over knot theory, and this is part 2 of my knot theory introduction. So in the last episode we briefly discussed the definition of knots and how to determine if a knot is its own type. So let's start by discussing the trivial knot. So this is the trivial knot, and it's also known as the unknot, because I guess there's not really any knots in here, and it's basically just a loop. In the last episode, we also discussed trefoil knots, but what we didn't discuss was that there's actually two different types of trefoil knots. Right here are the two different types of trefoil knots. We have the left-handed trefoil knot and the right-handed trefoil knot. And what you'll notice is that at each of the intersections, all I did was just switch the way that they were overlapping, which one is on top of the other. Now, we did need a way to organize these knots, so people did come up with many different ways to organize knots. There's knot theories, and there's knot invariants, and one of the more simple ways to organize knots is if they are prime or composite. Now, this doesn't really make sense because knots aren't really numbers. However, what I'll show to you kind of makes sense. So, prime knots are knots that aren't consisted of two or more knots by combining them. So what I mean is by adding knots. So we need to discuss what adding knots means. So let's start by adding two trivial knots. So what we do is we just detach a certain area of the knots, and then we connect them into one big knot. So the first step is to cut part of the knot for both of them and then attach them together. So this becomes something that looks like this. And if we simplify it, it just becomes another trivial knot. Now this adding function works with any two knots, and we can do this repeatedly with certain knots. And when we put them together, we make a new, totally different type of knot. And this is where prime and composite knots come in. So prime knots are knots that can't be written as a sum of two other knots. So let's say we have the trefoil knot. We can't write it as the sum of two other knots. Except one of the things that you must exclude when you're talking about adding knots together is the trivial knot, because you can write the trefoil knot as the sum of a trivial knot and a trefoil knot. So we have to exclude trivial knots kind of as a factor, just like how when we define primes for integers, primes can still be a factor of 1, kind of like the trivial knot. So now the normal way that we would organize knots is by crossing number, and this is used by most of the people who have a knot table. So crossing number is essentially the number of intersections, assuming that the knot is completely simplified. And usually when we make a table, it only consists of prime knots as to keep out all of the clutter. So the trefoil knot is, since it's one of the more simple ones and it has 3 intersections, we call it 3 with a sub of 1. And there's many other knots that have 3 intersections, so we'll have 3, 2, 3, 3, 3, 4, 3 sub 4, and so on. So this type of notation right here is known as Alexander-Briggs notation, and it's really easy to write primes in a notation. So overall, knot theory is a really interesting and weird topic that really isn't covered that much in school, and I will be covering more of these weird topics that really don't appear much in competition mathematics.